Good day everyone. So this is Miros Angel Aquino based in Math 3E. So today discussion is all about power series. So what is the power series? So in the definitions of power series is an infinite series of the form of where E sub n represent to the coefficient of the n term and C is a constant. Where power series are useful in mathematics in terms of analysis, where they arise as Taylor series of infinitely differentiable of the functions. So, what is the power series for? So it used to calculating the constants such as the pi and the natural logarithm base e and for solving differential equation. So a power series centered at e is an infinity series of the form. So we have a form of the summation of n is equal to 0 from to infinity e sub n x minus c to the power of n is equal to e sub 0 plus e sub 1, that is close and open parenthesis of x minus c to the rest of 1 plus the close and open parenthesis of x minus c to the rest of 2 plus and so on. Where n the infinity is equal, where n this symbol is, where n the infinity sign and n where n is equal to variable n, e sub n it is a coefficient of the n term, x is the variable of x, c where n represent of the constant. So we need to find a function. We need to define a function. So first, if x is equal to the summation of n equals to 0 from infinity c in the open and close parentheses of x minus a to the rest of n. But first we need to figure out the domain, that is where is the f actually defined for the word of i.e. for which it is x represent x. So thus the summation of n equal to 0 from infinity c n open and close parenthesis of x minus a to the power of n is a converge. So to analyze converge, if x a point of x and then treat treat of summation of cn the open and close parenthesis of x minus a to the power of n as a series just like before. Since x is fixed, so we can treat it like that, a constant, and analyze convergence at the series just like before. So first, what the c-in or what series test do you think we should start with? So you can start with of the series, you can use the ratio and root test. So for example, you can use looking for x for example, thus summation of n equals to 0 from infinity, so x to the power of n over n factorial converge for x is equal to 1. So we can plug in x equal to 1 into the sum, so that we're looking at this 1. So we are looking at this one. So we have this sum converged by either the ratio or the root test. So it meant yes. So for example number 2, what is x does summation of n equals to 0 from infinity, so x to the power of n over n factorial converge. It is converge. So for this kind of question, so let's apply the ratio or root test with x. In the series, you must be treating it as just some constant. Also, we can use the root test to determine that kind of series. So, this kind of series, so you can determine or you can use root test. So, we have a series of length and approach infinity, quantity of x to the absolute of x to the power of n over n factorial to the power of 1 over n is equal to lim n approach infinity, so absolute of x over n factorial to the power of 1 over n. So, len n approach of infinity n factorial over 1 over n is equal to infinity. So lem n I infinity, which can be shown easily with what? So we have the summation of n equals to 0 from infinity x n over n factorial. So we have x is equal to the real number. So that's all, and thank you.